Let's clarify the correct application of Carflex Conduit for hot tub wiring, focusing on relevant National Electrical Code sections. The inspector's interpretation of the code appears to be incorrect in this instance. Code section 680.42 A1 pertains specifically to flexible cords, dictating that they should not exceed 6 feet in length. This section is often misapplied when dealing with Carflex, which is a type of electrical conduit and not a flexible cord as defined by the NEC. Carflex, also known as electrical nonmetallic tubing or ENT, serves as a protective raceway for conductors, offering mechanical protection and routing for electrical wiring. Code section 680.25 permits the use of Carflex for wiring hot tubs, outlining the acceptable wiring methods and installation practices. This allowance confirms that Carflex is an approved method for providing electrical power to a hot tub, provided all other relevant requirements are met. Furthermore, section 356.10.5 addresses the usage of electrical nonmetallic tubing and, specifically in locations where it may be exposed to physical damage. This section mandates that raceways, including Carflex, exposed to physical damage shall be adequately protected. This protection typically involves securing the Carflex properly to prevent movement and damage. Securing the Carflex ensures that it remains in place and is not subject to undue stress or impact that could compromise its integrity and the safety of the wiring within. This is generally achieved by using appropriate straps or supports that are correctly spaced to comply with code requirements. Strapping the Carflex in accordance with section 356.30 ensures the Carflex is supported at specific intervals to prevent sagging or displacement. These straps must be suitable for use with Carflex and installed per the manufacturer's instructions to maintain the system's structural integrity. To summarize the correct application of these codes, firstly, section 680.42 A1, which limits flexible cords to 6 feet, does not apply to Carflex Conduit. Secondly, section 680.25 permits the use of Carflex for hot tub wiring. Thirdly, section 356.10.5 requires that Carflex exposed to physical damage must be adequately protected, typically through proper strapping. Therefore, you are permitted to use a length of Carflex greater than 6 feet, provided that it is properly installed and strapped in accordance with section 356.30. This ensures that the conduit is adequately supported and protected from physical damage as required by the NEC. Additional considerations for installing Carflex to a hot tub includes ensuring that all wiring within the Carflex is appropriately sized for the load it will carry in accordance with NEC tables and requirements. Proper grounding and bonding of the hot tub and associated electrical equipment are essential for safety and compliance with the NEC. The sub-panel feeding the hot tub should be equipped with a ground fault circuit interrupter (GFCI) breaker to provide protection against electrical shock. All connections must be made in approved enclosures suitable for the environment in which they are installed. Ensure that the Carflex is properly terminated at both ends, using fittings designed for this purpose to maintain a secure and watertight connection. Following these guidelines will help ensure safe and code-compliant electrical installation for the hot tub. When installing electrical systems, it is crucial to always consult the latest edition of the NEC and local amendments, as well as any applicable local codes or regulations. These codes and regulations may vary depending on the jurisdiction. Consulting with a qualified electrical inspector or licensed electrician can provide valuable guidance and ensure compliance with all applicable requirements. This is especially important for installations involving hot tubs and other specialized electrical equipment where safety is paramount. If there is any doubt or ambiguity regarding the interpretation or application of the electrical code, it is always best to seek clarification from the local electrical inspector or a qualified electrical consultant. Their expertise can help prevent misunderstandings and ensure that the installation meets all safety and code requirements. A proper installation not only ensures the safety of the users but also protects the electrical system from damage and potential hazards. Consider these general principles when working with electrical systems. Firstly, Always prioritize safety by de-energizing circuits before working on them and using appropriate personal protective equipment, PPE. Secondly, follow the manufacturer's instructions for all equipment and materials used in the installation. Thirdly, ensure that all connections are tight and secure, and that all wiring is properly supported and protected. Fourthly, test the installation thoroughly after completion to verify that it is working correctly and safely. Fifthly, document the installation with accurate records and diagrams for future reference and maintenance. Sixthly, stay up to date with the latest changes to the electrical code and industry best practices to ensure that all work is performed to the highest standards. Seventhly, seek professional guidance when needed, and never hesitate to ask for help or clarification when faced with unfamiliar situations. Electrical work can be dangerous, and it is always better to be safe than sorry. By following these principles and taking a meticulous approach to every installation, one can ensure that electrical systems are safe, reliable, and compliant with all applicable codes and regulations. Remember that electricity poses significant risks, and any mistakes or shortcuts can have serious consequences. Therefore, it is essential to approach every electrical task with the utmost care and attention to detail. Properly installed and maintained electrical systems provide a safe and reliable source of power for homes and businesses, contributing to the overall quality of life and economic prosperity. Conversely, poorly installed or maintained electrical systems can create hazards that endanger lives and property. Therefore, it is imperative to invest in quality workmanship and materials, and to follow all applicable codes and regulations. The electrical codes are not arbitrary rules but are developed based on years of experience and research to prevent electrical accidents and ensure the safe operation of electrical systems. By adhering to these codes, we can minimize the risk of electrical shocks, fires, and other hazards. When selecting materials for electrical installations, choose products that are listed and labeled by recognized testing laboratories, such as Underwriters Laboratories, or Electrical Testing Laboratories, et.al. These listings indicate that the products have been tested and found to meet specific safety standards. Use only materials that are suitable for the intended application and environment. For example, use waterproof or corrosion-resistant materials in damp or corrosive locations. When installing wiring, follow the correct wiring methods and practices. Use the correct size and type of wire for the load it will carry, and ensure that all connections are properly made and insulated. Protect wiring from physical damage by using conduit or other protective measures. Grounding and bonding are essential for electrical safety. Grounding provides a path for fault current to flow back to the source, tripping the circuit breaker or fuse and preventing electrical shock. Bonding connects all metal parts of the electrical system together to ensure that they are at the same potential, minimizing the risk of shock. Overcurrent protection devices, such as circuit breakers and fuses, protect wiring and equipment from overload and short circuits. Select overcurrent protection devices with the correct ampacity rating for the circuit they are protecting. Ground fault circuit interrupters, GFCIs, protect against electrical shock by detecting small amounts of current leakage and interrupting the circuit. GFCIs are required in bathrooms, kitchens, and other locations where there is a risk of contact with water. Arc fault circuit interrupters, AFCIs, protect against fires caused by arcing faults. AFCIs are required in bedrooms and other locations where there is a high risk of fire. Electrical inspections are an important part of ensuring electrical safety. Electrical inspectors review electrical installations to ensure that they comply with the electrical code. If the inspector finds any violations, they will require them to be corrected before the installation is approved. Regular maintenance is essential for keeping electrical systems safe and reliable. Inspect electrical systems regularly for signs of damage or wear, and repair or replace any damaged components. Clean electrical equipment regularly to prevent overheating and other problems. Test GFCIs and AFCIs regularly to ensure that they are working correctly. Always hire a qualified and licensed electrician to perform electrical work. A qualified electrician has the training and experience to perform electrical work safely and correctly. Be wary of unqualified individuals who offer to perform electrical work at a lower price. Their work may not be up to code, and it could create a safety hazard. By following these safety tips, one can help to prevent electrical accidents and ensure the safe operation of electrical systems. Remember that electricity is a powerful force that should be treated with respect. Always take precautions to protect yourself and others from electrical hazards.